Hi guys, this is Chaitanya here. I'm here to help you teach these final exam questions of general pathology, question number 17 and question number 18. And I will be mainly focusing on things which are missed by students and are expected by our department. The important thing to note is that these questions are rather overlapping. So don't worry about what is the answer for which, rather study the whole topic as a concept and try to integrate it with other things taught in general pathology and special pathology. Because the examiner can bring you to these topics even if you get a chronic inflammation question or a, let's say, proliferative phase inflammation question. So for our department, you have to understand the concepts and words like granulation tissue, reorganization, and the ability to integrate the concept of repair in many different diseases of systemic pathology, which you'll read this semester. So let's get started. First, I'll be describing you what is regeneration and what is repair. So in general, when you replace a damaged tissue with another tissue of its same kind, that is considered as regeneration. Now we all know from books and sources that we have three different kinds of tissues: permanent tissues, which cannot divide because they are terminally differentiated, and on the other end we have labile tissues which are continuously dividing, and then we have something called as stable tissues, which are rather having limited capacity to divide. But the key thing to remember in these things is that regeneration involves replacing damaged tissue with same type. But on the flip side, repair kicks in when we substitute a damaged tissue with a different kind of tissue, usually the connective tissue. So if a cell cannot divide, then the healing will take place by deposition of connective tissue and subsequent scar formation. It can also be valid for tissues which have some ability to regenerate, example your skin, but the damage is just too much. Even in those cases, you will see some fibrosis happening. Moving on to the next slide. This slide is the most important slide of this entire presentation. If you understand what this slide is trying to convey, then you're good to go, essentially. So when you have any injury, you have naturally inflammation at that site of the injury, which leads to increased blood vessel permeability, ultimately resulting in fibrinogen leaving blood vessels because it is exudated out because of increased vessel permeability. This fibrin then turns into fibrin strands, and fibroblasts start proliferating on top of this fibrin. And due to result of some complex cytokines leading to formation of new blood vessels. And this leads to formation of something which we call as granulation tissue, which the professors love asking what it is and what it is made up of. Each and every word of definition of granulation tissue cannot be missed. It is composed of fibrin, fibroblasts, and newly formed capillaries. And this granulation tissue is eventually formed, and over time it lays down collagen, and you have scar tissue formation or fibrosis. So let's apply this concept in various diseases of general and special pathology, because let's see, yeah. Now this is an example from hemostasis. uh, from Professor Dushkova's slide. And as you can see, you have a large thrombus over here. Normally in physiology, we read that the thrombus is supposed to be broken down by fibrinolytic mechanisms of the body, but if the thrombus is big enough, then the fibrinolytic mechanisms are overwhelmed and the thrombus is not dissolved. This happens very often in pathology and all pathological diseases. So as a result, you have in long standing causes of thrombus formation, recruitment of fibroblasts, and ultimately leads to formation of granulation tissue, which eventually over time again deposits scar in that area. I've drawn another example just to simplify this complicated scheme. So if you see you have a thrombus here, if it is not lysed by body's natural fibrinolytic mechanisms, plasmin, etc., over time it will recruit fibroblasts, capillaries, and ultimately cause fibrosis and scarring in that vessel. Now it depends how big was the thrombus and how much was the fibrosis, and the fibrosis may completely occlude the vessel or it may cause just a stenosis, just like I drew in this diagram. So this whole process of uh, long-standing uh, fibrosis or scarring in the blood vessel because of a not so large thrombus, like this whole process is called reorganization, or in this case we call it reorganization of blood vessel. Another example from special pathology I took, this picture represents stages of lobar pneumonia, again taken from Professor Vishkova's slides. As you can see, there is initially blood exudated out, hemorrhagic inflammation, the so-called hemorrhagic inflammation. During that phase, we call it red hepatization. Surprise, surprise, it looks red because blood is being exudated out. But eventually, 2-3 days later, the blood is lysed by the resident macrophages and only fibrin remains. Depending on the degree of damage, you can see lung fibrosis or you can see resolution, but the core issue remains same, that the fibrin which is there in fibrinous inflammation will form granulation tissues, granulation tissue which can undergo fibrosis if long standing. So if you have a large amount of fibrin exudated out, the chances of fibrosis, lung fibrosis, increase dramatically. Next example from bone formation, in which I took a photograph of my own robins. The bone formation process is also similar. I would say not exactly same, as you all know. As you all know that you've read 4 stages of bone formation. First, there's hematoma, then there's soft callus, then hard callus, and then there's remodeling of the bone. Using, I would like to introduce my concept of repair in these 4 stages and how you should explain it to the examiners. So as you can see, during stage 1, 0 to first day, there's a hematoma. Now, hematoma is nothing but a collection of blood. Blood contains again fibrin. So when there's extravasation and stasis of fibrin, that serves as scaffold for subsequent bone formation, leading to a soft callus formation. Second diagram. And later on, it ossifies. As you can see, even the process of bone repair has components of inflammation. Non-specific granulation tissue is formed. Later on, that soft callus is converted into hard callus, like because the osteocytes are coming over and depositing bone over there. And in the end, you have remodeling. So to summarize, the body's mechanisms for repair are not creative. The body only has two ways to repair something. Either it replaces by its own cells or it replaces by connective tissues. If you understand this principle well, you will be able to answer cross questions of complications of literally any disease professors ask you. For example, I included what would be the complication of chronic suppurative pericarditis. Now, if you imagine that then you have inflammation in the pericardium, some amount of fibrin must have been exudated out, and that fibrin will, over a period of long time, like chronically, will cause some degree of fibrosis. And since that fibrosis happened in the heart will not be able to relax. So therefore, you will have a problem in the filling of the heart, and that will lead to decrease in diastolic volume. I can add on more examples. For example, if you have a Crohn's patient and the inflammation in Crohn's disease is, let's say, transmural. If you have two transmural inflammations in Crohn's patient, you can form a connection between one intestine bowel and the other intestine bowel, which is called as an adhesion. So this is the main point which you should understand and try to let's say integrate it with special pathology. Thank you guys.